Welcome back to the Math Professors. If you enjoy content that can be found in any college math class, please consider liking, subscribing, and sharing. I'm Professor Van Hamlin. I'm going to cover degree and radian measure. So if we have an angle that's in standard position like this one, and what I mean by that is that the initial side is on the positive x-axis and its terminal side is somewhere in the xy plane. So it opens up this way, which is why we give our quadrants the names 1, 2, 3, and 4. The angles actually open up in the direction of those particular quadrants. Now, if I want to figure out, how to define angle measure, I really need to get a representation of what is, all the way around. So, and the way we do that is we say that the entire revolution around this, one revolution, we define to be 360 degrees. So we already know that this angle right here, this right angle, is equal to 90 degrees. So if I have this angle theta right here, which is that right angle, opens up in this direction. The reason why this is 90 degrees is I can see that, theta is, a portion of one revolution. Well, I didn't go all the way around, so it's not one revolution, it's 1/4 of one revolution, and one revolution we know is 360 degrees, so it's 1/4 of 360 degrees, which in this case is going to be equal to our 90 degrees, and so on. So if I have an angle that looks like this, positive x-axis opening in this direction, halfway around, this angle theta, we know theta is going to be equal to half of one revolution, or half of that 360 degrees, which is going to be equal to 180 degrees. Now a non-standard, standard position angle can also go in the other direction. This is going to be our initial, this is going to be our terminal side. But what happens if I open up in the opposite direction? Let's call this, angle theta. Now, angles that open in that opposite direction are going to be considered negative angles because they move, not in this direction, but the other way. So theta is going to be equal to negative. Now, in this case, I've sliced this thing into 1, 2, 3, 4, 5, 6, 7, 8 pieces. So this is negative 1/8 of one revolution, which is 360 degrees. And that's why in this case, this is going to be negative 45 degrees. Now our other form of measure is going to be considered radian measure. And radian measure comes from just, redefining what we call one revolution. So radian measure being equal to 2 pi radians. And this has to do with, if we're in radians, that the arc length is equal to the angle. So if we look at like a circle, I know that its circumference is equal to 2 pi times the radius. Now if I have a radius of 1, then this is going to be equal to 2 pi times 1, which means all the way around the circle is going to be equal to 2 pi, which will be equal to, our measure. So that's where our radians come from. Another way of looking at radians and how this, another form of where this comes from, is if I have this circle right here, and I say that this has, length r, if I map this around the circle at the exact same length that r is, that this is also r, of course this will be r as well because it's a radius, then this angle measure, this theta measure, is going to be equal to 1 radian. So this really is the true definition of what it means to be a radian. So that is when the radius and the arc length are equal. Alright, so now that I know one revolution is going to be equal to 2 pi radians, we can start doing portions of this thing. So let's kind of go back to here. What would this angle be? We already knew what this angle was as far as, what a right angle is. It's going to be 90 degrees. It's something we're very familiar with. Well, what does that turn out to be in radians? So in this case, angle theta, again, is going to be 1/4 of, 1 revolution. 1 revolution being 2 pi radians, so this is 1/4 times 2 pi, which is why we get our pi over 2 radians. Now, a lot of times when we do radian measure, if you see like a pi is in the angle, it's usually assumed to be radians. So a lot of times we'll just say pi over 2. Similarly, what if I have halfway around the circle? What about this angle measure? What we know is that theta is going to be equal to 1/2 of 1 revolution, 1 revolution being equal to 2 pi. So this is going to be equal to 2 pi divided by 2, which is going to be equal to pi radians. And even back to this. Even in radian measure, we can do a negative angle. And again, I've sliced this into 8 slices. So that means since this is, opening up in the, in the negative direction, so theta is going to be equal to negative, 1/8 of 1 revolution, which is equal to pi over 2. So that's why this is negative, 1/8 of 2 pi. That's why this is negative 2 pi over 8, which this is going to be negative pi over 4. And we'll get, very accustomed to doing this. This is 0 radians, this is 45 degrees or pi over 4, this is pi over 2, this is 3 pi over 4, this is pi, and so on. Now, we're very familiar with degree measure. It's something that we've kind of been practicing for, much of our mathematical career. So what I want to do is I want to be able to change from a known angle measure, say in degrees, and turn it into radians using what's considered a unit factor. And I usually start out with this. Like, if I want to go, if I want to know how many inches are in 3 feet, so if I give you 3 feet, I want us to determine, how many inches in 3 feet. So the way this is done is you take 3 feet and you have to multiply it by a unit factor, because I don't want to change the value of 3 feet. I just want to rewrite this in terms of inches. So what I know is for every foot, there is, 12 inches. And we do this in such a way that I'm trying to cancel the feet and remain the inches. So now you can see that the feet will cancel. So 3 times 12 is equal to 36 inches. So building a unit factor, the reason why we know that 12 over 1 foot is because 12 inches is equal to 1 foot. Therefore, if I take 12 inches and divide it by 1 foot, this is equal to the number 1. And similarly, if I do it the other way, I can say 1 foot divided by 12 inches is also equal to the number 1. So if I wanted to go from inches back to feet, I would use this unit factor instead. Now, doing unit factors for radians, what we know is that 1 revolution is equal to 1 revolution. So I would say 360 degrees is equal to 2 pi radians. Now, since both of these things are divisible by 2, I can divide both of these by 2. So 180 is equal to pi radians. So what I get is I get 2 particular unit factors. I can say 180 degrees divided by pi radians, I'm just going to leave that radians out of there, is equal to 1. And this is also equal to pi over 180 degrees, knowing that these things are in radians. So this allows me to transfer from maybe one measure to another, depending if I'm giving you degrees and I want radians, or if I'm giving you radians and I want degrees. So an example would be rewrite the degree measure in radians. So hey, let's do some common angles that we're somewhat familiar with. What about, let's say, 60 degrees? So what I know is if I want 60 degrees, this is going to be equal to 60 degrees multiplied by one of these unit factors. Remember that I want this to be in radians when we're done. So if I have degrees in the numerator, just like if I have feet in the numerator, I need feet in the denominator. So if I have degrees in the numerator, I need degrees in the denominator. And what unit factor does that? Well, it's going to be this one. So this is going to be 180 degrees, and this is going to be equal to pi. So simplifying this is going to be 60 pi over 180, knowing that the degree symbols are going to cancel. And 60 goes into 83 times, so this is going to be equal to pi over 3 radians. Now remember, we did this for 90 degrees. 90 degrees was pi over 2, so if we want to just verify that our unit factor is actually working, I can take my 90 degrees, I can use the exact same unit factor, which is 180 pi over 180 degrees. Remember, this is turned into radians because your degree measures are going to cancel, so this is 90 pi over 180, and 90 goes into 180 twice, so this is going to be equal to pi over 2 radians. As expected, we knew that's exactly what it was going to be. Now, if I want to go the other way, what if I'm giving you radians and I want to go back to degrees? Well, it's as simple as using that unit factor instead. So if I want you to rewrite the radian measure in degree, well, let's start out with, say, A is equal to 135 degrees. Not bad. I don't want that. I want 3 pi over 4. I might have just given you the answer, but we'll know in a minute here, won't we? So if I want this into degree measure, what I know is I'm going to take my 3 pi over 4, and I'm going to multiply this by this unit factor, because remember, I want the pi's to cancel in this case. I want the radians to cancel. So this is, pi radians. So this is in radians, this is going to be in radians, so this is going to be over 180 degrees. We can see that this, and I should write the radians next to it, although I did not, the radians will cancel. So this is going to be equal to 3 times 180. So this is going to be 540 divided by 4. Making sure. 135, as we expected. What about B? Say I want to take my pi over 6 and turn that into degree measure. Well, I take my pi over 6. I multiply this by the correct unit factor. Remember that I want the radians to cancel, so that's why pi is on the bottom. So then this is going to be 180 degrees divided by 6, should have the degree measure, which is going to be equal to 30 degrees. Now I explained to you how a radian was built, and I'm going to draw the picture back there, and I want to figure out what is the degree measure for a single radian. So really it's going to be a part C. So let's erase this piece here. And I want to do a C. What if I have 1 radian? What is this equal to? Well, I'm going to take my 1 radian and I'm going to multiply this by 180 degrees divided by pi. Now 1 radian doesn't have pi in it, so that's why we don't see the pi's cancel. So then when I take my 180 and I divide it by pi, I'm going to get around, let's make sure, 180 divided by pi. I want to say the wrong answer. That's what 57 point. So this is going to be equal to 57.2957795 blah blah blah. So we could approximate this about 57.3 degrees. I'm going to preface this with a really clever thing a friend of mine brought up. He's a pipe fitter, and he said, somebody explained to me that if I measure out 57.3 inches, and then when I start measuring around my, my arc, if this is 57.3 inches, and then every single inch on the arc will actually represent a single degree. And I will prove that to you in a short this weekend. So it's really clever, and the reason why is we are using radians, and that means the degree measure and the arc will share the same units. Okay, so let's kind of go back to what a radian is. Remember what a radian was, is if we're looking around this circle, if this is equal to r, and then if I travel around this circle, you know, at the same length r, then this degree measure right here would be equal to 1 radian. And by the look at that, that looks like about 60 degrees, so it makes sense that, you know, in this case, it's going to be about 57.3 degrees. So if you like the content, please subscribe.